Yo, yo, Ultra Brainiacs! Here we are. Welcome to the Johnson Kendro video hour.
But it's not an hour.
Yeah.
All right, today we're doing section 4.9, which is systems of equations, but today is a little bit different because we're going to have quadratics in there. So I got a little review here. Remember, graphing systems of linear equations. When we did that, we graphed our lines on the same coordinate plane, and wherever they crossed was the solution, and we got an x and a y value as our answer. We also learned how to solve them by substitution and elimination, but remember that it involved more than one equation, and the shared solution is at the intersection, and it made both equations true. We also did systems of inequalities, and when we do those are our lines that had shading on one side or the other, and then our answer was the overlapping shading. We're going to do those again today, but we're going to have quadratics. Okay, so just a quick introduction here. You're not going to have any questions like this, but just so you understand what's going on. We have lots of different options here. Sometimes you will have two solutions. So if you had a parabola and a line, this has two solutions because it goes through twice. Or you could have a parabola with a line that goes through...
Make that dot big.
and it crosses once. That is one solution. Or it's definitely possible for us to have a parabola and a line that do not cross at all. So that can happen, and you're going to see all sorts of those. So let's do one together. It says solve the system by graphing. I did put some steps up there for you. These are the same exact steps that we used back in 4.2 to graph parabolas from standard form. So I am going to do my work off to the side. Excuse me. So this first equation, the a value is 1, the b value is 6, and the c value is 9. The first thing I want to do is find the vertex. So I'm in equation 1 and I'm finding the vertex. To do that, you need to use opposite of b over 2a.
That cute little function.
That's right. So it's negative 6 over 2 times 1, which is negative 6 over 2, which is negative 3. That's the x value. Then to find the y, remember we plugged that in. So to do that, I'll have negative 3 squared plus 6 times negative 3 plus 9. That'll get me a 9 minus 18 plus 9 again. We end up with a 0. So the vertex on my first equation is negative 3, 0, which is there. Now how does the shape work? Remember that we looked at just the beginning part of that equation. We made a t-chart for just y equals x squared. We picked really easy stuff. And we got these kinds of points. Those tell you the shape. But we know that it's symmetrical. And we know that the vertex is now at negative 3, 0. So we want to recreate that shape over here. Okay, so that is one of my graphs.
A little shortcut too is remember this last number here is the y-intercept.
So maybe my curve isn't very good. It's supposed to be right there.
So you can also estimate it that way too.
And we do need to be careful with these because it is really important that our graphs are exact because we have to find the intersection. So sometimes we've got to fudge it a little bit.
All right, make those dots bigger.
That's right. Equation 2, that is a line. Phew.
Easy.
Yeah. Slope-intercept form, y equals mx plus b. That is my intersection, my y-intercept. So I'll be at positive 3. And then the slope is positive 1. Up 1 and over 1, as you can see, I'm getting farther away from the parabola, so I'm going to go the other way. And you should notice that I'm crossing twice at those two places. So I have two solutions, and I want to write down the coordinates. One of them happened at the vertex, so negative 3, 0 is one of the solutions, and then negative 2, 1 would be my other one.
Oh, that's kind of cool.
Look, you're sending me a message down there.
Hey, I wonder what I'm saying.
I don't know. Probably. Let's make math videos.
Yeah.
Okay, you try the next one.
All right, this one's substitution.
Oh, yeah, I remember this.
This is when the y's are alone. We can take this part and put it in for that y
Substituting.
There. Right. So x plus 5 equals negative x squared minus 3x plus 10.
So we want to have all x's in one equation.
Right. That you can solve. You can't solve when there's two different variables. So next I want to get everything on one side. Okay, so we did that. We're going to now get it in standard form. So So I'm going to subtract x, and I'm going to also subtract 5.
So you're getting everything on the right.
Yeah,
Okay.
it doesn't really matter. We might want to change the negative at the beginning here, but we can do it later. So negative 3 negative x is negative 4x. 10 minus 5 is 5. Now if you don't like that negative, we can factor it out front. So I can make this negative 1, then x squared plus 4x and minus 5.
Now, doesn't that also mean that we could have moved it to the other side?
Sure, you could move these that way to avoid having to do the negative 1 step. So whatever you're comfortable with, go for it. All right, the next thing we're going to do is we're going to factor this parentheses. Now, it's an easy one. It's got a 1 in front. Remember, if it has a different number, you might have to do the 4 blanks. But for this one, it looks pretty easy. So x squared is x and x. 5, my only choices are 5 times 1. And it's a minus here, so we have 1 of each. I need a plus 5, a minus 1 to get me that plus 4. So, what does this really mean? Each of these now I have to set equal to 0.
Now, wait a minute. What about that negative 1 that you took out? Is that going to change anything?
No, not for our answers, not for where they cross. Right now I could divide both sides by negative 1 and still get just the 0.
So that doesn't matter.
Yeah, those numbers you factor out just kind of float around, or you can get rid of them.
Cool.
All right, now we're going to set each one of these equal to 0. So I get negative 5, and then x minus 1 equals 0. Move the 1 over. X equals 1. Now those are just the x values.
Holy cow.
So these problems get long. So I have negative 5 and I have 1. I need to find the y values. So what we normally do is substitute them back in.
Should I pick the top one?
Oh, heck no. Wow, that'd be a lot of work. Let's do the bottom one.
Oh, that makes sense.
Right here, because that's so much easier. Choose wisely, Grasshopper.
Okay.
All right, so putting in our negative 5 first, I get negative 5 plus 5. Well, that was easy. So I put a 0 with that one.
That's one solution.
Right. The next one, I'm going to put a negative or a positive 1 in there. So y equals 6. So that's the other place where these graphs are going to crisscross.
Okay, that looks awesome.
Yeah.
These aren't so bad. They look kind of scary.
Yeah, it's just kind of a combination of skills we already know.
Good. All right, last one. These are systems of inequalities. So that means that we're going to have graphing and shading. I put some little hints over here for you. You want to graph. You might have lines and parabolas, or you might have 2 parabolas. This is actually 2 parabolas. So we're going to graph each of them. So again, I'm going to do my equations separately. Number 1, I got to find the vertex. We use the cute little formula, opposite of b. So that's 4 over 2. What's my a?
Negative 1.
Oh, good. Okay. That is, I'm just making sure you're paying attention over there. 4 divided by negative 2 is negative 2. Then, to find the y, we're going to plug it in. Remember, this is negative 1 out in front times negative 2 squared minus 4 times negative 2 plus 3.
Wow.
Negative 2 squared first is 4, but then we want to multiply by the negative. We'll get negative 4. Then negative 4 times the negative 2 will get a positive 8. And then I'm going to add 3 more. When I put the first 2 terms together, I get a 4. Add 3, it's a 7. So the first vertex that I have is at negative 2, 7. That is over here. And to decide what the parabola looks like, remember you make your shape chart. You can ignore the fact that that's an inequality right now. I'm just pretending for a second that it's not. Make my t-chart. That negative out in front means all your values are going to be negative. And that shape would have looked like this. But the vertex moved. So I'm going to put them all up here. Now, that was graphing. Now we have to decide if it's dashed or solid. Do you remember how we did that back when we were doing lines?
I sure do.
What did we do?
If there's an equal line with it, it's solid. And that one does have an equal line with it.
Solid line, and then light shading. Okay, this is, it says less than or equal to, so if you think about going below the parabola, that's actually going to be on the inside. So less than would be in there. Okay, but we're making it light. Okay, we got to do the second one. This one's a little easier though. This one, if you look, your B value, you can think of this two different ways. You can think of this as vertex form, in which this is a K value, or you could think of it as standard form, and if you were to do your cute little formula, there is no B, and you're going to end up getting a 0 anyway, and then you'd plug it back in, and you end up with a Y value of 3. That's my vertex that shifts up 3 units. Okay, then my chart for this one is just y equals x squared. Remember, you can ignore that inequality for a moment. Again, pick easy stuff. You'll get 0, 1, and 4. That would be this shape, but our vertex moves, so it's going to be up here. All right, now I need to decide dashed or solid. This does not have equal to, so it will be a dashed U. And this is greater than, so that's going to be above. So if you look at the overlapping area, it's not very big.
It's a little sliver there.
Yes, it is a little sliver. It's right in here. That's going to be my overlapping area.
Right. So we don't have just two answers. We got a whole bunch.
That's right.
Every shaded part.
Everything in that shaded area.
All right.
Okay, we'll try to pick problems that are pretty straightforward, easy to see the intersections. So.
Yes. All right. Ta-ta for now.